Now, welcome friends. This is session regarding bisection method. Bisection method is used to find roots or factors of polynomial f of x. This method gives factors of algebraic and transcendental, that is non-algebraic equation. This method finds at a time only one factor, and that is a real factor. Bisection method finds approximate root of polynomial by doing number of iterations. This method consists in locating the roots of the equation f of x equal to 0 between a and b. If f of x is continuous between a and b and f of a and f of b are of opposite signs, then there is a root between a and b. So here we represented a and b. This is the interval where a to the suffix minus or plus is nothing but f of a is positive or f of a is negative. Now let's consider f of a is negative and f of b is positive. Then the first approximation to the root is, so x1 equal to a plus b upon 2. So this is bisection formula. We are dividing the given interval into two parts. So a plus b upon 2. Now interval a and b become a, x1 and b. So in a and b we got here new approximate root, that is x1. Now if f of x1 is 0, then there is a root of f of x, a polynomial f of x. Let's consider f of a is negative from equation 1, and suppose f of x1 is positive. So here we given a to the suffix, that is minus already, and b to the suffix plus is positive. Now x1 we have assumed right now this is positive symbol. So our next interval is become a to x1, that is root lies between a to x1. So the root always lies between opposite symbol. Next approximation, that is second approximation, x2 equal to a plus x1 upon 2. If f of x2 suppose we will assume to be negative, then that interval a to b become a symbol minus, x2 symbol minus, x1 symbol plus, and b symbol plus. It means now for the opposite sign x1 and x2, so that root lies between in the interval x1 and x2. Then the third approximation become between these two values, so x3 equal to x1 plus x2 upon 2, and so on will continue. For example, find a root of the equation x cube minus 4x minus 9 equal to 0. Now this polynomial we consider here algebraic. Now this will solve by using bisection method. In the solution part, consider real numbers 0, 1, 2, 3, substitute in the given polynomial and find out the values of that f of 0, f of 1, f of 2, and so on. Now first value is minus 9, second minus 12, then minus 9. Now when we will get opposite sign, f of 2 is minus and f of 3 is plus. So at this step we claim that a root lies between these two values 2 and 3. Therefore first approximation to the root is x1 equal to 2 plus 3 upon 2, that is 2.5. Now f of x1, that is first approximation we find, that is f of 2.5. Now we will substitute in the polynomial and we got the value by using calculator minus 3.375. Now f of x1 is negative, so our interval become, therefore the root lies between 2.5 and 3. Since f of 2.5 now we got here negative, and f of 3 this is already positive, thus the second approximation to the root is x2 equal to now 2.5 plus 3 upon 2. Now next we will find f of x2 substitute this 2.75, that is x2 value, in the polynomial. Now we got this value positive 0.7969. Therefore, the root lies between 2.5 and 2.75. Since f of 2.5 from the second iteration is negative and f of 2.75 we got here positive. Thus, the third approximation to the root is x3 equal to 2.5 plus 2.75 upon 2. So we got here third iteration. Now, third iteration, that is f of x3, x3 will substitute in the polynomial, and now we got this value to be negative here, so minus 1.4121. That is, f of x3 is negative, therefore the root lies between 2.625 and 2.75. Since f of 2.625 is negative and f of 2.75 is positive, so always the next approximation will lies between opposite values of given polynomial. So here this value is negative and this value is positive. Thus, the fourth approximation to the root is 2.625 plus 2.75 upon 2, that is x4 value. So in exam point of view, we will perform maximum 4 approximation, that is for up to x4, but the question is approximate the given root till 3 decimal points, so that repeating this process and the successive approximations are, we find x5, x6, x7, x8, x9, x10 and x11. Now at x10 and x11 we got here 3 approximation. We have corrected this up to 3 decimal places. Now this will understood the first problem by using table format, where A is 2 and B here we assume 3, where 2 to the base minus is the symbol of f of 2 and 3 to the base plus is the symbol for f of 3. Now in these opposite symbols we have our factor or root. So x1, that is first approximation, is 2.5, that is addition of these two values divided by 2, that is 2.5. Now substitute this 2.5 in the polynomial f of x, so we have minus 3.375. So this minus sign will assume for this 2.5 suffix minus, so this minus and this 3 plus, so it become opposite, so the next interval become 2.5 to the suffix minus and 3 plus as it is. So x2, that is second approximation, become 2.5 plus 3 upon 2, that is 2.75. Now substitute x2 value in f of x. Now we got positive symbol. This positive sign will give to 2.75 as a symbol. So this plus and this minus, so that become our next interval, that is 2.5 and 2.75 plus. So we got here 2.625, addition of these two divided by 2 by bisection method, then this become x3, that is third approximation, 2.625. Again substitute this x3 in f of x polynomial. Now we got here minus sign, negative, so this symbol will give to this x3 value. So this minus and this become plus, with this opposite sign our next interval become 2.625 to the base minus as a symbol and 2.75 plus as a symbol. So they have this opposite sign, so that next interval become 2.625 plus 2.75 upon 2, that is x4, fourth approximation. Now we have continued this up to x11. N is nothing but number of approximations, so this we have performed by using table format. Next problem, find a positive root of the equation x e raised to x equal to 1. Now this is a polynomial, this is a non-algebraic equation which containing exponential function, or we call it as a transcendental equation. Now this problem, we will discuss by using bisection method. Again, each time we will substitute here real numbers. F of 0 we got here -1, f of 1 we got here positive 1.718. So with these opposite signs we have our first root in this interval. So root lies between 0 and 1. Therefore, first approximation to the root is x1 equal to 0 plus 1 upon 2, that is 0.5. Now this x1 value 0.5 will substitute in the polynomial f of x. Now this value is negative. So the root lies between 0.5 and 1 because f of 1 is already negative, positive, and f of 0.5 is negative, and thus the second approximation to the root is x2 equal to 0.5 plus 1 upon 2. So x2 is equals to 0.75. Now f of x2 will get here positive 0.5878. So f of x2 is positive, therefore the root lies between 0.5 and 0.75. Since f of 0.5 is negative and f of 0.75 is positive, so that next approximation x3 equal to this. Now f of x3 we got here positive symbol, so the next interval is f of 0.5 is negative, and f of 0.625 is positive. So x4 we got here 0.5625, and the root is, now we got here at fourth approximation, and we'll consider this is the root. Will not go ahead for more approximation in exam point of view. We can perform number of approximations, but still we calculated up to x4. Now this we put in the table format. This is first a value, b value, and this is the center of that is first approximation 0.5. Next interval become 0.5 and 1 because of symbol opposite sign. We got here 0.75. Next problem, find a positive root of the equation x cube plus x square plus x plus 7 equal to 0 using bisection method. Now intentionally we taken here this problem. Now substitute initially with 0, 1, 2, 3. Now we got 7, 10, 21, 46. So this is a increasing sequence, increasing function. So we will not get here opposite sign. In that case, we will consider negative values. F of 0 is 7, f of -1 is 6, f of -2 is 1, and f of -3 is -14. So here we got opposite sign at the interval -3 and -2. So we will assume this is the first interval. So x1 equal to -3 plus minus of 2 upon 2, that is -2.5, that is the first factor. We will continue. F of -2.5 is negative, therefore the root lies between -2.5 and minus of 2. Since f of -2.5 is negative and f of -2 is positive, so in these opposite signs we have our next approximation, that is x2. So x2 equal to -2.5 and -2 upon 2. So this is x2, and the same process will continue for x3. We have f of minus of 2.25 negative and f of -2 is positive, so that we will get x3 as next approximation. Now again we got here fourth approximation as f of minus of 2.125 is negative and f of -2 is positive. These are of opposite signs, so that next x4 we got here approximation. At x4 what we got, that will assume to be a approximate root of that polynomial. This we have performed by using table format. So thank you all. This is regarding the bisection method. If you have doubts, you can ask the queries or you can send me mail. Thank you one and all.